Hi everyone, welcome to our Tech Leader chat today. I'll start by introducing myself. Hi, I'm Christine. I am the TLC Community Manager, also a part of the Multitudes team. So for those of you who are new here, Tech Leader Chats is a community for human-centric engineering and product leaders to learn and grow. And Multitudes, we sponsor the community, so that's why we're putting on these monthly chats. Our goal as a company is to help engineering teams deliver on track sustainably. Cool. So for our session today, I'd like to introduce Vindhya. So Vindhya, welcome. Today we have her speaking on how to get buy-in to a technical roadmap at a startup. So Vindhya is a hands-on technical leader with over 20 years experience at a wide range of organizations, both large and small, including the likes of Unibuddy, JumpCloud, Microsoft, and more. So she is definitely no stranger to creating and getting buy-in to technical roadmaps. With that in mind, I will stop sharing and pass you over to Vindhya.
Thank you, Christine. Let me share my screen. All right. Hello, everyone. Kia ora. I'm very excited to be here as part of this vibrant tech community in New Zealand and truly honored to have the opportunity to share some of my learnings and experiences with everyone today. Thank you, Lauren, and thank you, Multitudes, for inviting me to this Tech Leader Chat. Briefly about myself, I started my career as a developer at Nokia Siemens, then worked at Microsoft for almost a decade before I moved into the world of tech startups. And in the startup world, I first worked with Unibuddy, which was an edutech company that I joined pre-Series A and stayed till post-Series B. Then I was with JumpCloud for 2 years, which was a scale-up. And now I'm working with Foodstuffs North Island, which is an enterprise scale business. So I've been fortunate to have seen a wide range of startups and experienced the problems that happen in each of those scaling milestones. Um, and as I was preparing the slides for today, one of the things that I kept struggling with was the headline for the talk: how to get buy-in for a technical roadmap. Now, we're all part of technology product companies. We build products to solve customer problems, and technology is just a tool that supplies or supports the solution. So the product leader creates the product roadmap, which defines what the product will deliver to customers. And the technology leader defines the technical roadmap, which outlines how the product will be built and what technologies are required in order to achieve the product vision. So what is the problem? Where is the problem? And then I remembered my days as a fresh team lead, working with an enthusiastic team of engineers on a new product. In the early days of the product being built, the technical roadmap and the product roadmap were beautifully aligned, evenly balanced. And the product leader would ask for feature X, and I, as technology leader, would say feature X coming right up. And in an acceptable period of time, feature X is ready to be announced to the world. But then I also remembered that as time went on, I often found myself at the receiving end of this question. And I'm sure we've all heard this from time to time. And I would talk to my mentors about how my team is working hard, sprint after sprint after sprint, and we're working as fast as we can. And yet, business leaders, product sales, customer success are unhappy about how long it took to build a new feature. And my mentors would suggest some things that I could try. And then I remembered that I would often find myself saying this: we're too busy. We don't have the time to try things out. And that's when I realized that the pertinent question that we all want to talk about, and that we all are wanting to share notes about, is how do we get buy into a technical debt roadmap? Because technical debt is what is causing us to, not as technical leaders, not be able to deliver with the speed, with the velocity that we want to, so that we can hit the business goals as quickly as we can. Sorry, I think I'm hearing some other crosstalk too. If you could mute yourself, please.
I've just muted them. Sorry about that.
No worries. Thank you, Christine. So the question that I had as a tech leader as an emerging tech leader, as someone who was kind of learning how to manage teams and keep delivering technical value to the business, was one, how do I manage technical debt so it does not become overwhelming and slow productivity? And the other was, how do I translate the impact of technical debt into a language that business leaders can understand so I get the time and the resources to address the technical debt? And that is the focus of my conversation here today. So I can present and I can talk about what I have learned over the years, and hopefully I'll be able to learn from you all too on what you're doing and what's working, and I'll be able to take that back to my work, my day-to-day work today. So let's take a look at what's the definition of technical debt. Um, I'm, I'm sure we all understand this inherently, but if we were to look at a formal definition of technical debt, Martin Fowler talks about technical debt as shortcuts taken or compromises made with a view to achieving short-term outcomes, resulting in deficiencies in quality, resulting in systems becoming harder to understand, harder to modify and extend, and resulting in additional unwanted effort and additional time needed for getting new features out into the market. And what causes us to take these shortcuts or make these compromises? It's typically time pressure, it is business priorities, it is knowledge or skill gaps in the team that leads to these decisions being made, right? So with that formal definition, let's look at again, going back to my journey. One of the questions that I had as as the team lead was, how am I accumulating technical debt? It's not that I'm an engineer who's very proud of my work and proud of what my team does, and I'm not wanting to accumulate technical debt intentionally, right? And what I learned over the years was that there are primarily two categories of technical debt. There is technical debt that is deliberately accrued, and technical debt that we accrue inadvertently without realizing that we are actually accruing it, right? And eh, some of the sources or the ways in which we end up accruing deliberate technical debt, what we will look at in the next few slides. So we have often, or we all will have some examples where we have made decisions where we did not fully consider or fully think through the consequences of that decision, right? An example from my own past is where I've had end-to-end test that was failing. It was a flaky test, and it would fail intermittently in the build pipeline. And when there is a feature that needed to be delivered on a tight deadline, we made the decision that, let's just disable the test because it's a flaky test. We do not have the time to go and fix the test before we deploy the feature into production. We deployed the feature, we did manual testing, we were happy with it, deployed it, and then life took over. We forgot about the flaky test that we had disabled, right? And surprise, surprise, after some time, we ran into an issue in production, which would have been caught by that test if we had learned or taken the time to go back and fix the test and re-enable it. So here is an example of a decision that was deliberate, but not fully thought through, right? It was not something where I paid enough attention to the consequences that would fall out from that decision, and it led to a technical debt that was accrued. And then there were decisions where I did not realize that I was actually accruing technical debt, right? An example of this is the first one here of not understanding database scaling early on. We did not anticipate the volume of data that we will be handling as our logos grew. We did not anticipate how much our queries would slow down with the growth and volume. And we did add indexing, but the indexing was not sufficient, or it was not what was needed to handle the data volumes that we were growing towards, right? And here it was not like we did uh, it was not a deliberate decision to say that, hey, we're not going to add indexing or anything reckless from that perspective. But the fact that we did not sufficiently look forward to anticipate how much volume of data was going to come in, and the fact that we did not put in the due diligence needed to plan for that, resulted in technical debt. And the result again was, slow queries, which leads to production issues, and we have to find ways to resolve it quickly. And that was again a type or a source of technical debt that we were accruing. Um, and then comes the good, what is called good technical debt. Um, and the first category here is where, again, these are not deliberate in the sense that, we're not deliberately choosing to accrue technical debt, but the decisions that we make end up causing technical debt. And the example that I have from my past is where we decided to use MongoDB, NoSQL DB, as our database. And this was done primarily because we didn't know all the metadata that we need to store for our entities. Um, but over a period of time, as we started building in dashboards and reporting, what we found was that we were pretty much using a NoSQL DB as a relational DB. And now we started to run into all the problems that come with, having to maintain relational data integrity in a NoSQL database, and the queries which are slow because of the data model that we have, right? So this is not bad technical debt. We want to avoid the technical debt that comes from decisions that are not, where we are not inadvertently or deliberately not thinking through the consequences. This is one where we thought through the consequences, but at the same time, we did not fully understand what the consequences would be, right? But the good thing here is that there were learnings that were taken back, and we had plans to address it, and we knew what we would do in order to address the technical debt. And the last kind, which is deliberate decisions to accrue technical debt, knowing that we are going to address it and with a plan to address it. And this is the best kind of debt that we would accrue. My own example, and this I'm sure this is an example that pretty much every startup has, is to start with a monolith when you're building the solution, knowing that we're going to move into microservices architecture later, but the monolith is what gives you the quickest time to market, and it's the right decision to make at the point. So technical debt is something that gets accrued, and it is in the real world, it is hard to avoid technical debt, right? So now what we need is strategies for managing technical debt. And when we think about strategies for managing technical debt, one of the things that I keep in mind is the knowledge that the more technical debt accumulates, and the longer I do not address technical debt, the harder it becomes to address it, right? And it's very similar to financial debt. The interest starts to overwhelm you, and it is prudent to keep that in mind as we're planning to address the technical debt. So what are the strategies that worked for me? Over my years, I found that in order to address technical debt and to manage it, there are three things that we should pay attention to. The first is to track and measure. Um, in
Cool.
if we don't know how much debt we have, if we don't know how what it's going to take to address that debt, then it becomes very hard to know to plan for it and to actually action it, right? So tracking and measuring is the first strategy. The second is to minimize. Now that we have an understanding of how technical debt is accrued, um, similar to in healthcare, we say prevention is better than cure, right? So minimizing technical debt and making sure that we do not accrue technical debt that is not necessary is another strategy. And the third is to actually figure out how do we keep addressing technical debt on a regular basis. Sorry, just give me a second. Okay, so how do we track and measure? What I found really useful was to make sure that there is a well-groomed, regularly updated technical debt backlog maintained, and give it the same due diligence as we would do for a product backlog, right? Often when I joined, for example, when I moved to new organizations, what I found is that there's a lot of technical debt related knowledge that is sitting in the heads of, principal engineers and product owners and, senior engineers. And it was not tracked in any place. And what would happen is that there was no way to have conversations about the technical debt because it is nebulous, it is vague, and there isn't a common understanding of what exactly needs to be addressed and how large is the debt, right? So keeping that backlog and putting in the due diligence to keep it refined, keep it story pointed so that you know how much debt exists was something that I found to be extremely useful. And there is this concept of the tech debt ratio, which is an industry standard now, which essentially is taking the total tech debt story points and spreading it across the sprint velocity to understand how many sprints will we need if we were to decide to just focus on addressing technical debt. How many sprints will we need in order to completely clear all our technical debt, right? And here, one of the things to keep in mind is that the complexity increases as debt increases. If you remember the slide about the interest that gets accrued, so the story points will have to be adjusted if technical debt has been sitting around for a while. So what was the original complexity estimated may not be the case when you're looking at it, a few sprints later. Also related to that, there is the concept of a debt ceiling and a debt baseline. This is something that I am starting to use now. I have not used this previously, but I think this agreeing to a debt ceiling, which is once you have the debt ratio, agreeing to a ceiling beyond which it becomes, everyone agrees, the business leaders and technical leaders agree that it becomes ineffective for the engineering teams to produce value at a reasonable velocity, and productivity drops if debt goes beyond the ceiling. And having some processes in place which will trigger that alarm and trigger the process for looking at technical debt as something that needs to be addressed with immediate urgency is something that's useful. And and also the concept of debt baseline, because at some point, the return of investment of addressing technical debt starts to drop low. If you've addressed it enough, that sufficiently that the teams are productive again, and it's at that point we should shift the focus back to product and customer value features. So now that we have a way to track and measure technical debt, how do we focus on minimizing it, right? Remember, again, the less debt we accrue, the easier it is. So things that I found useful, the first thing was build just enough, right? As engineers, it is tempting to try and build for scale before there is the scale that warrants that. And yes, scale is something that this is a topic that has led to a lot of discussions, because architects and engineers typically want to plan for scale and build for scale. But I've had CROs and I've had business leaders who are like, let's wait for the scale to come before we address it, because what happens is building for scale requires time and requires design, and it takes longer to go to market with the feature if there is more focus put on scale. But again, it's a delicate balance. There's also debt that gets accrued if we do not put in sufficient thought for how much scale we need to build for, right? So hence the point about build just enough to be able to deal with the scale that we are anticipating in the in the midterm future. Another thing that I found that helped a lot was truly embracing the mindset of agile, which is about iterative development. And part of being able to develop iteratively is being really comfortable with refactoring, right? Embracing refactoring as a way of writing code. So you're not trying to kind of create that perfect service or the perfect function or method right up front. It's okay to write and rewrite and rewrite and refactor as you go, and then you reach the structure that makes the most sense. And there were some things that I have learned are non-negotiables and that I hold as non-negotiables, because compromising on these will lead to a lot of pain in the future. And these are the things that I um, take the time to educate people about, especially engineers and also the business leaders and product leaders, that it's worth investing time and effort in loosely coupled design, highly modular code, automated unit tests, automated functional tests, documentation that lives with the code, automated deployment processes. These are table stakes. These are things that we should not negotiate on, compromise on. Couple of other learnings: carefully evaluate tech choices, because industry, there will be trends. There will be new tech which looks really interesting, which everyone wants to try out. But the question to ask ourselves is there sufficient experience and expertise in our teams to be able to make the right decisions for that tech? If not, do we have the time to invest in training and upskilling the teams? If not, going after the trendy tech might actually end up accruing a lot of technical debt. My own example is one of using GraphQL. GraphQL was the emerging technology of the time. Really, really good technology with a lot of power. But then because the teams did not understand how to use GraphQL sufficiently, we ended up using it in a way which caused a lot of complexity in terms of, how the backend needed to support the queries that were coming in. More learnings about how to minimize technical debt. Non-functional requirements I found were a huge source of contention because and what I learned was that non-functional requirements is something that gets not explicitly called out, and there are misunderstandings about what the non-functional requirements or how much is will the product support, right? And this could be in terms of scale, this could be in terms of security, in terms of reliability. So what I found was that it is important to align and have a clear shared understanding of what are the non-functional requirements that need to be met, and these need to be factored into the cost estimates, right? It's not getting something out there which does not support let's say SOC 2, which is not SOC 2 compliant, is much easier to do than to put in all the checks and balances needed in order to make it fully secure. Establishing standards and best practices is another learning of mine. An example here is where the team started to use Kafka for asynchronous communication between microservices, and we had not put in standards and best practices for topic naming, right? And soon we had this proliferation of topics that were named every different way, and there's a lot of work that we had to do post facto in order to bring that back to a standard naming format. And again, with standards and best practices, it is important that we get team buy-in and we automate where possible so that they are automatically enforced and it doesn't require a lot of process to enforce. And it's also good to have champions who will, in each team, they will basically uphold or ensure that the best practices are being followed. And this one about building in small value increments and getting feedback early. I think this is something that is very obvious now, but again, this was a hard learned lesson from my early days, where the tendency was to try and build everything. It also required in order to build in small value increments, it also required a lot of partnering with the product leaders so that we are able to identify these thin slivers that of vertical functionality that we can get out to the customer and get feedback on, right? So there was a lot of partnership needed for that, and from there, one of the things that I learned from one of my product leaders was to have the concept of cut lines. And we would have, 2 or 3 cut lines for every feature. And, the first cut line would be would be the MVP cut line. If we did not build up till that cut line, the feature was not valuable enough to a customer. But beyond that, every cut line would be like a pause point to reassess, should we continue working on this feature? Or are there other features that we need to look at? Or have we built enough that we can now wait to see and learn customer behavior and use that opportunity to address technical debt and maybe in other areas? And now, how do we address technical debt once we have accumulated or as it starts growing, right? And here, what I found to be really useful, and we will go into more details about how exactly you can look at identifying the value of tech debt. But at a basic level, the idea was that identify the value of each tech debt item that you want to address, identify the effort, and this is where again maintaining that backlog comes into picture, having that story pointed epics, user stories comes in really useful, right? And you can categorize your tech debt into the quadrants of um, small pieces of work, which can be fill-ins. And these I found were really good to use as fill-ins for sprint buffer, right? So usually when you're planning your sprints, you leave a little bit of buffer to accommodate unanticipated requests that might come in, customer issues or bugs that need to be handled, right? And if you have that buffer, these fill-ins can be taken or brought into the sprint. What I like to do if there's a lot of tech debt that I'm trying to work through is to have dedicated capacity allocated every sprint so that I'm actually working through the tech debt backlog at a steady pace. And I also found that these were typically candidates for onboarding new hires and interns, right? Because these are small enough items that can be used to gather or to gain knowledge about the system itself. And then there is the category of big wins. So these are the low effort, high value items, right? These definitely the dedicated capacity allocated every sprint was a must for this. I found these to be good for good candidates for slow periods. For example, if you take what is it, a production deploy shutdown during Christmas, for example, the team can focus on big wins, right? And we can get a lot of value just by focusing the team on that and making progress on it. I've also seen other team leads use the concept of dedicated sprints every quarter. So every quarter, the first sprint would be about addressing these low effort, high value tech debt items. And in JumpCloud, we had every 6 months we would have a fixathon, which is basically 3 days that would be just about focusing on these big wins, right? And get as many of the entire engineering team was focused on big win tech debt clearing. So these were some of the tactics that were used for addressing technical debt. Um, I think the hardest category are the ones that are big projects. So these would be things like you have to refactor a monolith, or you have my example was a highly coupled monolith, which basically made it really, really difficult, really expensive to add a new type of user that we wanted to, or a new type of role that we wanted to support in our product, right? And it required a lot of refactoring. We wanted to pull it out into a separate microservice so that it can be, so that it can scale on its own. But the problem was that um, it was a highly coupled design at the storage layer, and we had these massive queries that were joining across a lot of tables, and it would take a lot of time and effort, not just to write the code for the new way to approach the problem, but also to test it and make sure that that we are not causing any regressions or issues for current customers. So these there were two approaches that I've seen taken. One was to have a dedicated team or squad focused on that. And the other was where essentially we took the whole project, and then we broke it down into multiple phases, and each phase was like a incremental value delivery, where we're not fully addressing the tech debt, but we make sufficient progress that we are unlocking some value for either a feature or for a team, for another team. And then we continue on to the next phase. So here again, there isn't a one size fits all approach. It depends on the unique problem that you're trying to address. But then there are ways in which we can each team can come up with solutions for how do we address this. But what is needed here, as you can see, it's a big project, right? It's high effort. So what you need is, here is where the buy-in conversation needs to come in. Here is where you will need to have the conversation with the business leaders to get the resources, the funding, the time that is needed in order to address that. So the question now is, how do you have the conversation? And what's needed here is to speak the language that business leaders will understand and be able to communicate what's the business impact of the technical debt item, and also be able to communicate how will addressing that particular technical debt item add customer value, right? Because ultimately what the business wants is to add value to the customers. And here is where I found that using a framework, this is a ThoughtWorks framework. There's also a framework from Google, which I did not find as useful. I like the ThoughtWorks framework better. But there are, this is generic enough that you will, once you see this, you will realize that you can come up with your own framework for categorizing technical debt. What kind of technical debt that you have is it that you're trying to deal with, right? So there's code quality related debt, there's coupling, unused features, out of date libraries, reliability or performance problems, you have manual processes, you have testing gaps, knowledge gaps. It's different categories that you can kind of club technical debt into. And once you have the categories, you can also see that what's the impact, or what does that kind of technical debt lead to from a business perspective, right? And these are the risk categories. These are the risks that the business is facing as a result of having unaddressed technical debt. And the risks are, and these are the categories that I have come up with for myself. Reduced frequency of deployments. These are the DORA metrics, essentially. Increased lead time for changes, increased change failure rate, increased mean time to restore. Limited ability to innovate, because now you can't add new features because it's that there's so much of possibility of either causing regressions or you just can't add features without having to do a ton of rework, right? It may be really difficult to make security improvements. For example, if you are on older versions of dependent libraries and frameworks, you may have a lot of security issues which are unaddressed. You may not be able to scale. It will be difficult and slow to onboard new users. You'll have developer frustration. So these are the risk categories. Again, I would say that for each organization, for each organization, it is good to come up with your own frameworks for what are the debt categories and what are the risk categories, right? And once you have the debt and the risk categories, then it is essentially classifying the technical debt into what's the debt category, what are the risk categories that map to that, and then doing a risk assessment matrix, right? What's the impact of the risk? Is it high, medium, low? What likelihood of the risk, effort, and value? And this classification then makes it really simple and easy to have the conversation with the business leaders in terms of the urgency and the cost of addressing the technical debt. And in this conversation, what I realized was that as technical leaders, we should not feel that it is just our responsibility alone to address to handle this, right? Technical debt is a whole business problem. It's not just an engineering problem. And I think it is really important to have really good partnerships with product leaders and customer success leaders in this aspect, because product leaders can help really identify what's the impact of technical debt on the strategic product roadmap, because product leaders are able to see ahead to what's coming up and they'll be able to say that, okay, if it's going to cost so much to scale, then it is a problem because it's going to slow down our logo growth, right? Customer success leaders can really bring in the perspective from the customer's point of view. If addressing, or taking new features to production is slow, if you're not able to, if deploying anything is taking too long, we can kind of see the customer or correlate that to customer satisfaction scores and the number of customer issues and escalations that we're seeing. So having that three amigos kind of relationship where we're looking at technical debt as a shared problem and bringing that perspective was something that I found to be like really effective when it came to managing technical debt, right, and addressing it. So key learnings, just putting it all together. If I have to pick, what I would say makes the most impact in terms of remembering what to do. Establish standards and best practices early, avoid or minimize tech debt as much as possible. That's the best strategy. Be disciplined about paying off tech debt in small increments whenever possible, because there will be some tech debt that you accrue. But then as long as you're disciplined and keeping that the total tech debt to a low number, I think that is the best way to go about it. Quantify the risk that is accrued with technical debt so you can have those conversations and be able to allocate capacity to address it in a disciplined manner, and network with other stakeholders so you're able to both clearly quantify the impact of the debt and also be able to forecast or broadcast what that the technical debt is going to cost in terms of opportunity if it is not addressed in a timely manner. So that was me, and I'm going to stop sharing now.
Thanks so much, Vindhya. That was awesome, especially the point about the three amigos. So I was nodding along to that one. Cool. I'll reshare one moment. Awesome. Yes, James will share the video and the slides and everything after the fact as well. I just saw your note in the comments. But before we jump into Q&A, just a quick slide. If you could please share any feedback that you have for question survey, and then also if you're not already a part of our Slack community, would love to have you jump over there too. We'll pop those links in the comments. So we're gonna start with a couple of questions that we already had sent through, and then we'll open up the floor, conscious that we have 10 minutes left. But the first one, Vindhya, is engineers in my teams are getting stuck in their own way. They don't want to develop or take small steps as they're optimizing for solving the whole problem perfectly. Instead, tech debt and therefore new features don't get done. How do you get engineers to understand that velocity isn't achieved by trying to boil the ocean?
Right. So here, and I have seen this happen, and I must say that when I was early in my engineering days, I myself was like this. I was like, I have to do everything. Oh, I have to do this also, that also. But what I found was that it is a focus problem, and partnering with the product leader to right size the user stories and right size the incremental value delivery was the first step to solving this problem. Because as soon as you have a user story which is like really focused, it gives the engine, at least in my case, right, and I'm sure this is what applies to many engineers, the problem is that we are trying to solve what we think is a complete problem boundary, right? So defining that boundary very clearly in partnership with the product leader sets the boundary up front so the engineers can go focus on that boundary, right? And then when the question comes, what about this or what about the next thing, there is the next iteration or the next increment which will address those questions, right? That alleviates the engineer's concern that we're not addressing these things, and then they can focus on the specific boundary that needs to be addressed first. And as the engineers see that this works, I think they will get better and better at it.
Awesome, thank you. Quick next question, and then we'll open up the floor. How do I forge the roadmap of novel tech based on technical project where this person, the author, may not have sufficient expertise on each component or haven't worked directly on those components?
Yeah, the really good question, really pertinent, because I am kind of in this place right now in Foodstuffs, where we are trying to figure out how we use AI tools for increasing the productivity of the engineering team. Right, I have not worked on that in that area before, completely new to me. And here, I think the way I'm approaching it, and I think this makes sense in the case of anything where we don't know, we don't have the full expertise in that area, is to start small, right? So what we're doing is we're going to run a proof of concept, which is a really small bounded context that we are going to operate in. And we are going to try and find we're going to define what is it that we want as the outcome, what is it that we want to learn, and how are we going to learn it, and do it with a small team, run it as an experiment, and then use the learnings in order to then define what the strategy for the longer term is going to be, right? So start small, experiment, learn, and then apply the learnings. I think that probably is the only way and the best way to go about it. You could get experts to come in and help, but there's nothing like having your own experience that informs your decision making. I hope that
Awesome.
answered the question.
Yeah, I think that's great. Thank you. Cool. I'll stop sharing there. And did anyone have any questions? Feel free to unmute and just ask away, or if you wanted to pop it in the chat, I can read it out. Yeah, Lauren.
I can kick it off if there aren't others. So first of all, thanks, Vindhya. So useful, so practical. There's so many things that I can put into practice. So this question's inspired by some of the discussions in the chat and things I've seen. Let's say someone is joining an organization where there's already a large amount of tech debt, so it's past the point of being able to try to minimize it in the first place. How would you think about paying that down while still having a feature roadmap that business leaders are expecting the engineering team to deliver on?
Right. Good question. And it happens quite often, right? Because often organizations are focused on finding that product market fit, and getting like there's a lot of market pressure that happens. So tech that does get accrued. But once you have accrued tech debt, I think the first thing that needs to be done is to understand the tech debt, right? So make it clear what are the tech debt pieces that impact different parts of the product, right? And once you have that, then I would say that for every milestone that the business is planning going forward, look at what are the tech debt pieces that relate to making that milestone um, easy to achieve or quick to achieve, or what the ones that are directly related to that, and prioritize that, right? You don't have to, like, there doesn't have to be a tech debt addressing strategy or train that runs in parallel to the product train, right? They need to kind of go hand in hand. So find the tech debt that most relates to what is the customer value delivery that is being planned for, and address that. And as you keep doing this, you'll find that you have taken off a bunch of the tech debt and addressed it already.
Awesome. Thanks, Vindhya. Did anyone else have any questions? Feel free to unmute and ask away. Or Lauren, did you have any follow-ups?
Danielle came off onto video. Did you have a question you wanted to ask?
Always.
Go ahead.
Vindhya, great talk, and I love the use of the comics at the start. You mentioned the idea of having like a fixed allocation of time for addressing tech debt, which is a great place to start. Is there any downsides to doing this?
I think the main thing that I have found is, again, if there isn't that conversation between the tech leader and the product leader, right? There can be friction because
Mm-hmm.
there is always a huge product backlog, right, of things that need to be done, and
Mm-hmm.
the time that is allocated in every sprint to technical debt is coming from the time that could otherwise have gone towards new features, right?
Mm-hmm.
So it is, again, I'd go back to the Lauren's question also. It is important to be strategic about what tech debt you address in each
Mm-hmm.
of these allocated or dedicated capacity allocations, right? The more you're able to streamline that and align that towards the feature work that is going on, the more
Mm-hmm.
successful that strategy is going to be. And it is also helpful for the team itself, because now you don't have the team working on not working on two parallel tracks, right? The team can work as a single team and they're talking to each other because they're working on
Mm-hmm.
the same problem. One part is about new features, the other part is, I phrase it as prerequisites to building those features, because the
Oh yeah.
addressing the technical debt actually makes it much more faster, simpler to build that feature.
It's part of the health, isn't it? Yeah,
Right.
you made the point around non-functional requirements as well. So if they can see the connection to what, how these things connect to the performance and the speed, and these are other things that your end users experience as well,
Yep.
then it's easier to prioritize. Yeah, cool. Thank you.
Awesome. We've probably got time for one last question. Any takers? No, no,
I
cool.
can
Okay.
do a quick one, which is just can you just tell us a quick story of a time you had to have a tough conversation? Like there was something that was very clear that needed to be done. And yeah, there was a tough conversation involved with, business leaders to get that across the line. Can you just tell us, how did you navigate that? Like what was the situation and how did you navigate it?
Of course. So I'll go back to I think this is one of the hardest pieces of technical debt that I've had to address, and this was where we were using MongoDB when we should have used the relational DB instead, and we had this on top of that. We had these queries which were highly coupled across multiple collections. And just adding a new role in the system was so difficult, because it would impact lots of queries, which would impact lots of pages in the product, and there was no easy way to do it, right? And here it was a large project in order to take that extract that service out. And interestingly enough, it was a project that we had to iterate on, or essentially have three separate attempts at getting that project across the line, because each time we approached it, because of the complexity, because of the amount of coupling and the volume of data, and because of the fact that we couldn't take downtime in order to address this, right? Because this was all about the users of the system, and it was in the identity service. So it was in a critical piece where we couldn't take downtime at all. Our first attempt, the getting buy-in for the first attempt was easy, because the expectation was that, oh, it will take about 2 or 3 sprints and we will be able to deliver it. But then as we dived in was when we realized that it was going to be much larger than that, right? So then it was about, again, back and forth conversations with the business leaders. There was a lot of education that we had to do in terms of why it was taking so long, because that was one question that came up. You've been working on it for so many sprints, it's not done yet. Why is it not done yet, right? So trying to explain the complexity that we are dealing with, trying to talk about, there was a lot of conversations around what is it that we are doing in order to address that complexity? What have we tried? What has failed? What is a new approach that we are taking? And why do we believe that the new approach will work? And what's the new strategy that we are using, right? So initially we had multiple teams working on, or small parts of multiple teams working on the project. And then next approach or strategy was to have a dedicated team working on the project. And then we changed our technical strategy from trying to kind of refactor within the monolith itself to saying that, we're going to leave the old logic and the old data as is, and then we'll build a new one that stands on its own. Again, the important piece was having that relationship with product and customer success and architecture in order to clearly articulate the business value that we are trying to impart, and having a multi prong approach where we clearly articulate learnings from the previous iteration, how are we applying that, and what is our strategy if we fail, and how can we fail quickly and learn from that. I think that was what helped.
Awesome. Thanks so much, Vindhya. We're at time now, so probably going to call it there. Big thank you to Vindhya for sharing all your knowledge and insights today. Really appreciate it. All the time that you've put in and all your insights, and to everyone for joining. Thanks so much. As we've said, we will be sending up a follow-up email, and then also sharing the recording and notes on the Multitudes website. So keep an eye out for that. Otherwise, we're going to reshare the links in the comments. If you haven't joined our Slack community, please do so, and we'd love to hear any feedback. But otherwise, enjoy the rest of your day. Thanks so much.